Let's talk about John Dalton. He was an English school teacher who lived from 1766 to 1844. What he did during his time as a teacher was he spent a lot of time experimenting with gases, and through that, he was the one who was able to discover the law of multiple proportions. But while this is, pretty impressive, his biggest accomplishment yet is probably his atomic theory that he's proposed. This is a picture of Dalton himself. And we'll be talking in this video lecture about his atomic theory. Now, he has mainly 4 points in his atomic theory. One is that each element is made up of tiny particles called atoms. Atoms of a given element are identical. That's number 2. Number 3, chemical compounds form when atoms of different elements combine with each other. And number 4, chemical reactions are reorganizations of a chemical reaction. Okay, let's start with the first one. All matter is made up of tiny particles called atoms. And you might be asking, all matter? Yes. So everywhere you go, even though it might not look like it's, you can break it down further. For example, let's say diamond, right? Are you going to tell me diamond is also made up of tiny particles of atoms? Yes, right? If you zoom in enough into the diamond, and I'm talking several thousands of times of magnification, inside one diamond, you have little atoms bonded together, to be specific, carbon atoms. So, the same carbon you find in carbon dioxide. These carbon atoms are bonded together, and their bonding allows the diamond to have that solid, hard, glistening shape. Okay, it's the properties of these atoms and the way they're arranged that allows diamond to be the way they are. How about water? Yes, water is also made up of tiny particles called atoms. You have, now, in the case of diamond, it's just one kind of atom. It's just an element, right? So all you have are carbon atoms. Everything in diamond is carbon. Whereas with water, you have an oxygen molecule. This is oxygen. And this is hydrogen, right? So what you have is you have one big oxygen molecule and you have 2 hydrogen molecules bonded to an oxygen. And this is what makes up water, okay? Anything you see, for example, the food that we eat are also made of tiny particles called atoms. Most commonly it's in the form of glucose, right? So we have 6 carbon atoms bonded to, 6 oxygen atoms, and those oxygen atoms are bonded to hydrogen atoms as well as some carbon atoms. So everything you see, everything around you, all matter, and even, matter that you can't see. The air, is 72 to 78% nitrogen. Okay, nitrogen gas. Nitrogen is also an element and an atom. Okay, so everything around you is made up of tiny particles that you can't see. We can't see these particles because they're so incredibly small, but they are there. They bond together and several billions of times that allow us to make everything we have, from steel to, our pillows, to anything really. Everything we have around us, if you zoom in enough, you're going to find atoms there. And it's their bonding and their properties that allow us to have the wide variety of substances we have on Earth. Okay, moving on. Atoms of a given element are identical. So, I have 4 elements over here. Oxygen, okay? We haven't learned this yet, but this will mean the atomic mass of oxygen, and this will mean that it has 8 protons, okay? But we haven't got there yet. Just know that for each element, each atoms of a given element are identical. So one oxygen atom with another oxygen atom will be identical. Now, this part of the atomic theory is not 100% correct because isotopes exist, and we will talk about a little bit later. But know that chemically they are fairly identical. Okay, so know that atoms of a given element are identical. So a carbon atom will be one carbon. It doesn't matter if this is carbon atom number 1 or carbon atom number 2. They'll be essentially the same. Okay, it doesn't matter if it's if you get a copper atom from China or a copper atom from Hawaii, they're gonna be identical, and so is uranium and every other element on the periodic table of elements. Each given element is identical. Finally, chemical compounds form when atoms of different elements combine with each other. What does this mean? We'll use an example of water. Okay, we have oxygen bonded to two hydrogens. This is a chemical compound. It's a compound because we have different elements in our compound. Okay, it's not just an oxygen bonded to an oxygen or a nitrogen bonded to a nitrogen bonded to a nitrogen. It's one oxygen and two hydrogen atoms. Okay, and because of that, it's a compound. And chemical compounds form when atoms of different elements combining with each other. So another common compound is carbon dioxide. It's when a different element from oxygen, these two oxygen atoms are identical, as given from the previous point of the Daltons atomic theory. These are identical, and they will bond to a carbon to make carbon dioxide. There are most of chemistry, in fact, is compounds. So a lot of organic chemistry deals with carbon bonded to a different element, hydrogen. Even our ionic substances like salt, NaCl, these are two different elements. This is a compound, and these are when atoms of different elements combine with each other. And finally, chemical reactions are reorganizations of a chemical reaction. I have a picture here of the combustion of methane gas. Okay, you have this black atom represents carbon, and these white atoms represent hydrogen and carbon. Okay, and these red atoms you can hypothesize represent oxygen. Okay, and you can see that due to the conservation of mass that we talked in the previous video, we have 1, 2, 3, 4 oxygens on this side, and we have 1, 2, 3, 4 oxygens on this side. Okay, and on top of that, the carbon atom, we have one, and it's the same one over here, right? All we're doing is reorganizing our chemical reactions. We're not changing an oxygen atom. We're not turning an oxygen atom into a hydrogen atom, or turning a hydrogen atom to a carbon atom. They are just rearrangements. In this case, the oxygen are no longer bonded with themselves and are bonded to either a carbon or a hydrogen. And same thing here. The same thing with the hydrogens. The hydrogen begins bonded to the carbon, but now it's bonded to the oxygen. So it's just reorganizations of a chemical reaction. And those are the 4 points of Dalton's atomic theory. To recap, each element is made up of tiny particles called atoms. Atoms of a given element are identical. Chemical compounds form when atoms of different elements combine with each other. And chemical reactions are reorganizations of a chemical reaction, similar to the law of conservation of mass. That's how I help myself to remember it. And the key here is that you're not changing an atom to another atom or an element to another element. You're just rearranging the elements that you start off with. Okay?